We've got some lovely seats down here at the front.
We want to use drag and drop building blocks to be able to deploy these systems.
Hello, welcome back to Cloud Native Media.
About 4,500 streams.
Thank you very much for joining, watching, coming, doing whatever you're doing.
Our largest customer is DirecTV.
We've got Patrick here. We've got James in the US somewhere.
End users in the MCR should not know anything about code.
Hello, James. Can you see us?
I can indeed. You can hook the inputs and the outputs together.
These guys are going to talk about orchestration. Over to you, Patrick and James.
Thank you. Good evening. We're founded in 2008. We're a company that produces monitoring and control software, or NMS, or OSS, depending on your point of view within the industry, but all network monitoring and control. We're based in San Diego, which is where James is. And our largest customer in the US is DirecTV, who have about 4,500 streams, which is all managed by us on about 150,000 devices. So that's not all cloud, that is much more, hardware based, but it gives you an idea of the kind of things that we've worked on. In recent, or almost weeks, but certainly in recent months, there's been a lot, we've had a lot of interest and a lot of questions about being able to agilely control or agile orchestration for cloud services, where it's one thing to always have an engineering team to put things together, but at some point you need to hand everything over to an operations team, and they have to have some really simple agile tools to be able to work with. So that's what people have been asking us, so we're trying to see whether we can bring a solution that meets those needs. Partly, of course, we need some feedback from everybody as to what those needs really are, because each person has a slightly different idea, I'm sure. So, without further listening to me not saying very much, let's hand over to James, who will take you through the presentation in detail. Okay. James, you on?
All right, thank you, Patrick. Thank you for having us at this meeting tonight. And obviously, here in San Diego, you guys are enjoying beer, and it's not quite late enough for me to be to partake with that. But we're just going to go through what our vision from a cloud-based orchestration platform is. And as Patrick said, we're a software house. We build tools that our customers are finding useful and helping them in their day-to-day jobs. So obviously you guys are the experts when it comes to cloud native media and cloud-based orchestration and all of those good things. We have some experience of it, but from a very myopic view from a particular customer that tasked us to orchestrate all of their sporting events through their cloud-based platform. So obviously, we're here today to sort of facilitate and get feedback on exactly what our approach is and see, does it fit the market? Are there any ideas that we're not covering? But we are trying to make this agile, easy to use platform that pretty much any user can then build simple orchestration workflows and then deploy them. There's going to be a lot of overlap actually between the talk I'm going to do today and what Jamie was talking about earlier. We actually do a lot of our AWS infrastructure as code through the CDK, so we are familiar with that interface. We already have an integration with it. In fact, that's how we are configuring and spinning up all of our EC2 instances all through that CDK process. Where we kind of differentiate from the CDK and the implementation from AWS is we are trying to be vendor agnostic. That includes your infrastructure, your cloud infrastructure. So if you want to run on AWS, if you want to run GCP, if you want to run on Azure, that's your prerogative, and we're going to provide you tools that will fit that need and be able to traverse those different infrastructure platforms. The other kind of area that we differentiate really from the earlier talk from Jamie is we sit a slightly higher level because, as Patrick said, our background is monitor control. We already have interfaces built to all of the media hardware and media services, and we provide access to that through our systems and our platforms. So really, we're going in not just at the infrastructure level, which is great. Setting up all of the infrastructure is obviously very important, and making sure that it's all configured correctly and secure is obviously a major hurdle. But once you have that up and running, you may also want to interact with your elemental encoder. You may want to look at status, configure it on the fly, make changes that may not have been within that infrastructure definition. And that's where our services come in. We already have those integrations to those products. And the idea here is that we can make it easy for end users to make modifications to cloud deployment without really having to know too much about the underlying infrastructure. We sit at a level slightly above the actual infrastructure itself. So because we are a monitoring control solution, we have all of the API integrations to things like the elemental encoders, the packager, to Grass Valley's AMP systems, to harmonic VOS. So we already have those APIs written and are available through the monitoring control side of things. And we're making that available through the orchestration platform as well. Obviously, the talk today, I want to talk about the design processes that we're going through right now. Hopefully, this is going to be a two-part presentation. So this first part is going to be really, we're at step one, phase one of designing this platform to meet our customer needs. As Patrick said, we are looking for feedback and for you guys to get involved with this design and development. We're not the cloud experts. We're software guys. We do have one customer that we do orchestration in the cloud for, but really, you guys have a lot more knowledge and expertise in this area. So we are looking for some of that feedback and help us drive the direction of the design and the implementation of this platform going forward. Quick agenda. I'm obviously going to go through what we see as the basis of the cloud-based orchestration platform, the benefits of it, some of the key concepts and the architecture that we're putting in place, some of the implementation challenges that we've already come across. We'll look at the design. I've got a few very early prototypes that I want to show you, just to give you sort of a taste, a flavor of what's to come, and then we'll wrap it up with some conclusions and questions and answers. Coming from a linear monitoring control sort of background with workflows, they were often siloed, and they were very vertical in terms of nature, and there was a small team putting together those workflows. That doesn't necessarily scale well and doesn't transition well when we start looking at cloud-based platforms. It's a lot more collaborative. There's a lot more input to it. So obviously, things are changing. The nature, the workflows are changing. The nature of the business is changing, and we're trying to match that with this new product. So, what do we see as the basis of an orchestration system? So it's got to be a centralized system managing the end-to-end network, the production from start to finish, obviously putting up EC2 instances, connecting up edge devices, tearing it all down when it's done. Those are kind of the key points of what an orchestration system should do. So it should automate that process. Again, takes out of that element of risk, takes out that element of error. If you have users building these things, obviously a lot more efficient in terms of time, have the system do it for you. Making it simple to leverage the power of cloud computing. So how do I get my signal into my cloud deployment? How do I manage it throughout the various different stages? And then how do I make sure it gets distributed to the end user? Obviously, key functions of that are going to be automation. We are going to be, as we develop this platform, we're going to be relying a lot of the core capabilities of Mosaic. Mosaic already has a automation engine built into it, so we're reusing a lot of that capability. One of the newer sort of areas that we're adding to the platform is resource management. Traditionally, in a linear broadcasting environment, you have a fixed number of devices. They're already allocated to do something. When you start moving into elastic environments, such as cloud deployments, you may want to bound how many resources you can throw at a problem. And being able to do that resource management is also a key sort of factor of the orchestration system. And then finally, the sort of workflow element to it. How do you piece things together? How do you build a workflow for doing whatever production you need to do within the cloud environment? Obviously, there's some benefits you're going to get out of this. Obviously, scalability, being able to quickly spin up and spin down resources. There should be a cost-saving element to this, and that's kind of covered in number 5 as well. But effectively, you're only going to be using infrastructure when you need it. And obviously, with an orchestration system, you can plan those activities out, have the system provision all of those resources, handle whatever event you're dealing with, and then once that production is complete, you can tear everything down and obviously save cost that way, but also you can scale to you're not limited by physical hardware anymore. You can just add more instances to it, and away you go. There's an efficiency. Jamie alluded to this earlier. If you've got to spin up lots and lots of cloud EC2 instances, then doing that manually is not a good approach. We are integrated with the AWS CDK, so we can actually, start up, shut down your stacks, and control the infrastructure through their APIs. So you get a lot of that same efficiency. You can actually do it directly with our tool as well. You also get a collaboration element. So obviously with COVID, people have been working remotely. They have been, it's a lot more distributed in terms of a work environment, and being able to provide tools to collaborate across, geographic areas is obviously a good thing from that perspective. And usually when you're doing cloud media events, you're not all in one physical location anyway. You may have cameras at the event site. You may have a production team at another location. I know we're doing some work with ASG, and they're looking to do fully cloud-based productions where people could be hundreds, if not thousands of miles apart, and the system just has to work. And that kind of factors into the accessibility as well. 2 and 3 are kind of bound together. 3 and 4 bound together in terms of being able to manage these things from anywhere around the globe is a powerful thing. Obviously, we talked about the cost savings, so I don't need to cover that again. So one of the key components of the architecture, obviously, unlike CDK, we are agnostic to the underlying infrastructure. So we will run quite happily on AWS, Azure, GCP, no problem. If you had private cloud deployments, I know there are some around, as long as they've got APIs that sort of follow the same base patterns, then we can write providers or plugins to integrate with those. So one of the advantages is you're not tied to a given cloud infrastructure that you may have one that you want to use, but we don't care. We also can manage all the peripheral equipment as well. So managing edge devices, getting your data into the cloud, and then obviously, if the CDN is your final destination, then you're great. But if you need to then pull it out of the cloud to other equipment, maybe you want to do a stream that gets fed into a satellite uplink. There could be edge devices on both the ingest and the egress of that cloud infrastructure. So making sure that we cover not only the cloud infrastructure, but all of the equipment that goes around it. We always talked about orchestration engine. How do you actually configure these? The idea of the flow of data through the infrastructure, and that's then handled by sort of the resource management, making sure we don't exceed certain constraints, and also the automation to have that reproducibility that we can run the same output every single time. So here's a quick sort of throwback to what we were doing from a Mosaic standpoint. So this particular customer, we were looking at sporting events, and they were doing a OTT streaming service. So the idea here is, through Mosaic, this is not the orchestration platform. They would have a series of timed events that they want to fire off at certain times. The system would automatically provision all of the equipment within the system, and then at go time they could make that live, and then manually they could terminate and pull it back down again at the end of the event. Now that's very great. That's all good and well, but if you have different topologies, different configurations, then this kind of bespoke orchestration kind of starts to fall apart. It makes a very cumbersome approach from an engineering standpoint. So although orchestration is fully possible within the Mosaic platform, the sort of feedback that we've had from our customers is we need to be more agile. We need to be able to change the configuration and the flow. We want to introduce new equipment on the fly that wasn't maybe previously accounted for within the orchestration platform. So we quickly realized that Mosaic itself was not going to be the platform for doing this cloud-based orchestration. We needed something that sits above it, that can support all of the sort of user needs that go with it. So we moved away from that pretty quickly, and we started to come up with an architecture where basically we have an orchestration engine that sits on top of Mosaic. So we're still using a lot of the capabilities and sort of the underlying mechanisms that are within our core product, but we're providing a orchestration engine that allows the users to interact with it in our system in a very different way. So we have the orchestration engine dealing with the UI, the how do you actually build a media workflow. That all then gets fed to Mosaic. Mosaic takes that information and makes it a reality. Plugging into the sort of lower end on the Mosaic side, we have automation scripts that are providing some capability in terms of how the orchestration is played out. We are integrated with the CDKs of the world, so like the AWS CDK, so we can actually, do the infrastructure as a code through Mosaic. But we're also integrated with all of the various different hardware APIs, not only on-premise, but also in the cloud. And then how do we make that all work? Well, right now we're designing what we call TDLs. They're basically the Tapestry definition language, and Tapestry is our code name for this orchestration platform. I don't know if the name will stick, but that's what we're calling it right now. And then the TDL is basically for every device, every function within the orchestration engine, there is a corresponding TDL. And the TDL defines basically the capabilities of that particular element, that building block within the orchestration engine. One of the things I should say is, we're trying to get to a no-code, low-code solution for the end user. Now, that doesn't mean there's not going to be some engineering effort to build these building blocks, but effectively, end users in the MCR should not know anything about code if we do our job right. They'll be able to drag these building blocks onto a thread or a Tapestry element workflow, be able to configure it up using just protocol information, what IP address, what multicast is it on, that kind of information, and then hit deploy, and then the system will take care of the rest. So that's kind of the target, and that's why we differentiate from the CDK, because that's the infrastructure as a code. Well, this is trying to go one level above that and say, well, we want to use drag and drop building blocks to be able to deploy these systems. Yeah, there might be a lot of code on the back end. Our services team's definitely going to have to do a lot of the legwork, and obviously engineering teams at a customer site would have that same capability. But the MCR users, the operational side of the house, should not have to deal with code in that same way. Obviously, data security, making sure that when you deploy those infrastructures, that we are protecting the sensitivity of the media assets that we're dealing with, making sure that there's no loopholes or any security constraints or issues with that deployment. Integrating not only with the cloud-based assets, but also with the on-premise hardware as well, so that we can do a seamless integration across both. I know, we're focusing on the cloud as part of this talk, but in the most real-world examples, at least the customers that we've dealt with, yes, they want to move to the cloud, but they still have resources and equipment that are on-premise, so that they still need to handle both. One of the other things that is kind of unique about our approach as well is that once you've built your deployment, you want to monitor it, right? So once you go live with a deployment, you want that live real-time monitoring capability, and that's obviously what we do as a core business. So being able to take that orchestration element and then build from that the live monitoring of that same event, kind of there's no middleman. We don't have to, it's all part of the same platform, so we get it almost for free. And then obviously the optimizing the cost and the resources used is obviously a big factor, trying to keep driving costs lower for our end users. So what does a Tapestry description language look like? This is the sort of core building block of our design as it sits today. It's a JSON structure, and it basically is self-describing, and it says all of the capabilities that a element within the Tapestry orchestration engine can do. So it will define all the inputs or the outputs. So, if it's a MW Edge stream device from TechX, it will define it can have N number of inputs, it can have N number of outputs, how you configure those. These are the protocols that it supports. These are the capabilities of that particular element. So when you drag an Edge, MW Edge element onto the workflow, the system will know what those capabilities are. And it can get quite complex, so I'll just quickly show you an example. I don't want to spend a lot of time on this, but this is for an AWS subscription. So within our system, it defines, can you create a new AWS instance? Yes, you can. If I create a new one, what information do I need to be able to properly provision that? Well, I need you to give me a name for the instance. I need you to choose which AMI, which Amazon machine image you want to run on that particular instance. And then there's a whole lot of other options that you can select from here. But this is defining exactly what, if you wanted to provision an EC2 instance within our system, that's what it would look like. And similarly, there's the MW Edge, where we can define what an edge device looks like within our Tapestry platform. So these are, obviously end user configurable. You could add your own instances so that you can, orchestrate more complex devices. One of the things that we're doing internally from a development standpoint is we are actually going through, and all new devices will have a TDL built alongside the driver integration. But we're actually going back now and looking at the ones that are most relevant for this orchestration platform, and actually going back and adding the TDL, so this definition language of what the device can do within the system, so that it can be plugged in and be part of Tapestry, our orchestration platform. Well, the other things that the TDL does, not only does it drive what the user can select and do on the front end, it also will automatically be compiled into mosaic elements that will allow it to drive basically automation, how we pull data from that equipment, how do we process the information from that device. So there's the flip side to this. Not only is it driving the orchestration, but it will also be the cornerstone for driving the monitoring as well. And I've already shown an example, so I don't need to go through that. So what does it look like? What's the UI going to be like for defining a new, we call them threads, but effectively it's a workflow within Tapestry. Well, here's an example of an AWS EC2 instance. So in this case, the UI element will it's not going to look exactly like this in the final design, but effectively I've got this is an existing EC2 instance, so I've got an encoder one. I can have multiple applications running on it. Each application can have either, it doesn't have any inputs, it has outputs, or it has outputs, no inputs, or some combination thereof, defining in the TDL. And you will then be allowed to basically drag and connect things together in a very graphical way to build up the workflow and the media flow through the cloud infrastructure. So that's just a quick example of an AWS element. When you start looking at things like the MW Edge, it's a lot clearer about how that device operates and what its capabilities are. So in this case, we've just got an edge stream. I can have n outputs, I can have n inputs. Those inputs can be different protocols, so you can even do container-based protocols like 2022-7, where you can define the elemental input streams to it. But the idea here is that we already know what the capabilities of the stream within an MW edge are, so we make it available to the end user. And then there's another one we were just doing for mock-up, which was a tag MCM 9000. So, at the end, you might also want to actually throw it up on a multi-viewer and be able to plug it into, for example, a tag MCM device. So again, a bit of a mock-up, and I do have an early prototype which I can show you in a little bit more detail. But effectively, you'll have a sequence of devices that are available within the system that you can choose from, and then you would just drag them on and drop them into the swim lanes that you see on the right-hand side of the screen. And it should be as simple as that, right? So if we do our job right, it will make it very simple for end users to build up these flows. So what does it look like when we start building up? Well, in this case, we've just got an EC2 instance that's going to generate an output stream. It's then going to be hooked up to other parts of the system. We may want to flow that into an edge device, and then maybe off to either a CDN or to a tag for multi-viewer. So the idea is that it's very easy to just drag and drop these things onto the display and then hook them up. And because you're hooking up an input to an output, then you only have to specify what protocol it uses once, what if it's multicast, what multicast address it's using. All of that information gets specified once and gets applied to both the input and the output. It also means that you can't, it can do some constraint checking and say, okay, you want to take a HLS output off the EC2 instance to maybe a device that doesn't support HLS as an input, then it wouldn't be allowed, because the system can police that and make sure that you can only hook things together that can be hooked together. So here's an early prototype view of where we're going with this. So that the listing on the left-hand side, those are all your devices. You can drag them on to the workflow, and then you can configure them up. So this is just here showing configuring of the output properties of this particular stream. I can give it what its protocol is, its multicast address, port number, and all that. And it, everything is defined within that TDL in terms of all of the elements, whether it's the configuration of the overall device, all the way down to the individual streams and what the outputs and inputs, the capabilities are of those particular pieces of equipment. And then the idea is, once you've got it all together, you can hook the inputs and the outputs together and build basically a workflow graphically within the tool. You can then save it. You can save it as a building block that will then be used as its own element within the left-hand side. So you can build more complex collections of objects that then get bolted together in a parent workflow to build a more complex workflow. But effectively, from a user standpoint, it's as simple as just dragging and connecting lines together, setting up multicast addresses, things like that, all the configuration that's needed. And then come going live time, there will be the ability to deploy that, and the system then through Mosaic will take that, run all the automation to configure the workflow end to end from ingest through to delivery. So that's a quick prototype. Obviously covered a lot of information in there, but really just talk about the conclusions. Where are we going with this platform? What are we trying to do? What's the essence of what we're trying to achieve here? And basically it's trying to provide a tool that makes it very simple for operational teams to build workflows and have those deployed in a reproducible, controlled manner, and then be able to monitor that workflow, make sure that the end platforms, the infrastructure was set up correctly, all of the endpoints, all of the edge devices are properly configured, and then be able to effectively monitor that production in a live manner through Mosaic. We do have some complexities we have to deal with. Obviously, there are so many variants of devices and combinations of capabilities, and how do we capture that and how do we model that in a way that makes sense from a user interface perspective? That's kind of where we sit right now. Is we're building an internal schema for the model that we are using to drive not only the user interface but also the backend code to do the deployment. But it's a mammoth challenge because there's so many variations. Different equipment have different capabilities, and building a model that's both flexible enough to handle all those different cases, but also expressive enough so that it's obvious what's going on, is kind of where we're trying to hit that sweet spot right now and build that model correctly. We've also got some challenges around making that UI as user-friendly and as simple to use as possible, while still having all of the complexity that you need on the back end to be able to do it. We are introducing another layer in there that allows an engineering team to basically build their own automation and their own elements that plug into Tapestry as well. So there's going to be that element that we have to bring back into the loop. But also, one of the challenges that we face is, we're software engineers. We know software well. We can talk to APIs. We can talk to interfaces on equipment all day long. Building something that is ultimately going to be very useful to the end user is kind of where we are looking for that feedback from industry experts. And obviously, you guys, everybody in the room today, and also on the live stream, have a lot of experience and have a lot of use cases that we may not even be aware of. So having that input from the industry, making sure that we are covering the needs of the industry and make sure that what we develop is useful for the industry going forward, is kind of where I see the biggest challenge right now. And obviously, we've taken the step. We come from a traditional monitor control platform. This is a new step for us. This is, we see this as important to embrace this technology in order to stay competitive within this industry. So, we're investing in it, and we're inviting people to invest with us to basically build a good platform that is ultimately helpful to the wider community. So thank you very much for taking the time today to listen to us talk. If anybody's got any questions and I'll answer them, I'll be happy to take those now.
I'm assuming this is not an open source solution, just harking back to HashiCorp earlier on. But from a model, you were talking about cost reductions for users. Number one, is Mosaic in the cloud already?
It is, yes.
Okay, wasn't sure. Okay. And is your solution also going to be able to be cost aware, so that your system is being priced on a SaaS model, so that the cost for that is going to scale up and down as utilization is used? And does that apply to Mosaic and Tapestry?
Yeah, so we do have a SaaS license model with Mosaic. So yes, it can scale based on usage. That will be the same for Tapestry as well. So we will be following that same licensing pattern going forward. And at this point, we haven't. We're still sort of setting out on this course. So it may be that we do open source Tapestry, but then its usefulness would be questionable without using Mosaic on the back end. So
if I'm a sports broadcaster and I do a lot of football at the weekend, will I pay for it on Saturdays and not for Sundays and Mondays and Tuesdays? Or do you see how that model would work? I know that my AWS costs are there when I'm using it and then when I'm not. And my costs for the rest of the solution can be the same.
Yes, so that's where the SaaS model comes in, right? So you would be able to, if you are, only using it at the weekend, that's all you will end up paying for.
So it's per minute or per hour then, yeah.
Yeah, it's going to be not only by how often using it, but it's also going to be through the number of events that it's handling or something like that. But that's something we are, we're open to suggestions.
I guess it's the industry's expectation. It's a pay per use rather than pay per month, et cetera, et cetera.
So. Correct, yeah.
obviously a core part of the product is the UI and the ability to do the drag and drop build from that. Do you see other sort of interfaces being like a primary interfaces into this? So do you see that generating artifacts which you're then storing into, say, something like Git, and then versioning, and then those being edited and moved through a pipeline? Or do you see all the source of truth always being that UI for the drag and drop? So I suppose my question is, do you see that as the sort of initial design phase, which then generates assets, which then get passed on through a sort of GitOps or other process? Or do you see that as being like always the source of truth?
So where we see it right now as Tapestry will be the design tool that you use to build what we call threads. And a thread is the element that you would then version control, either through Git or through SVN or whatever the version control platform that you choose to use. That thread by itself is just the definition, right? So it's almost like the code that goes into your infrastructure as code. Until you deploy it or you do something with it, it's just a definition. That's it. But that would be version controlled, and you'll be able to do all your auditing. It's just a JSON file, so you can do all your diffs and all of that to see the deltas between different versions of it. But that element then will be used by Mosaic to, or potentially other systems, right? We're not. It would be an open schema for what defines what a thread looks like. But you need something to take that then and actually action on it in the DevOps environment. So that's where Mosaic would come in from our side. It would take that thread definition, and when you deploy it, that's when it will obviously go through and allocate all of the resources and configure them, provision them for whatever event that you may have.
Cool. Thank you very much.
David is back.
Sorry, I'm blaming David. He made me think of something I should have asked. So it sounds like Tapestry might have an API that I could call to make requests, and that your UI will be using that API to manage itself. There was some kind of REST API that I'll be able to use remotely.
Yep. So
Okay.
all of our interfaces, we use Swagger to document, and there will be a external REST-based interface to Tapestry. So you would be able to interact with it from external systems. What that API looks like right now is it's still early days. It's still going through development, but there will be some form of REST API that will allow you to hook this into a wider ecosystem.
And then via that REST API, we can upload new TDLs and then build a construct that represents a media processing workflow, which we can then name and then call through the API to apply it to a larger macro task.
Yep.
Cool. Thank you.
Yeah. So the idea is that the TDL, that we will provide a subset of the TDLs that are possible out there, right? So we'll build TDLs for all of the equipment that we already integrate with, that makes sense to be part of an orchestration platform. The big element where the sort of end user community comes in is they're able to build TDLs for anything that maybe fits within their media workflow. And then you would, through that REST API or through the UI, there'll be an option to deploy TDLs directly through the UI. You don't have to do it through the REST API, but if you want to build it into a larger pipeline, then yes, absolutely, you could deploy that through the REST API. And then you can even, as you say, build threads, which are the elements where the media workflow is defined, have that, deploy it through the REST API, and then also request that it be activated through that same REST API. So effectively, everything you could do from the UI, you can do through the REST API. Is a good point. Typically because we're using the same API, so it has to exist anyway to support the front end. So if you can do it through the front end, you'll be able to do it through the REST API.
And as a follow-up to that, is there sort of infrastructure in place or processes in place to allow various customers to share these assets share what they've defined? So you're saying one customer can define this. Is there a sort of community aspect to this of one customer being able to put the effort to define, and then that being shared across multiple customers?
I definitely see that as being a good benefit from this. So yes, I would like to see that community build around that, and we'll probably publish the TDLs in something like GitHub that allows people to then pull those and obviously, add to that list. But we'll have to figure out exactly how we do that. But I would definitely like to cultivate that community engagement.
What was your market analysis on this? Because what you say is you have a visual composer, which does all this in and output stuff, and then you compile it somehow to orchestration platform. Doesn't it sound a little bit like this IoT thing, or if this and that, where you have a lot of inputs and sensors and they go out in the flow, which is already out in the market in some ways or not?
Well, there may be. I know there's already UIs that do very similar things, like Node-RED is another example.
For example?
Of it. Yeah, I mean, the idea here is though that this is very media centric, right? So we don't as a company, we are focused entirely in the broadcast industry. So all of our APIs, all of the equipment that we integrate with are industry standard broadcast equipment. So, and we see the cloud being exactly the same. So, when talking to a Harmonic Voss, talking to Grass Valley Am, these systems, you won't find connectors for them in Node-RED. So although it's the same idea in terms of being able to graphically plug things together, it's for a different target market.
True, but back to David's question, then the UI is important because you do monitoring as well. So you could display the status of a resource as well on the UI, and it's interactive in one way. So that would be to your advantage, right?
Yeah, exactly. So that's where we see, this is a nice add-on to what we already have in terms of the monitoring, and it also bridges that gap, right? So having a graphical language to be able to define these things, but then be able to deploy them and monitor them in a real-time system, that's really where, ultimately we're going to be doing this to help the sales of Mosaic. But you're right. There is a gap there, and that's where we see the Tapestry fills that gap by providing that definition that we can then use from the monitoring perspective.
Hey, so it's more about the just configuration element of the drag and drop features. So
Yep.
You say you interact with AMP. So if I want to set up a FreeME keyer on AMP and have 10 camera sources connected into, just say a Simply Live, and I can drag and drop that throughout your software. Can you set up all the parameters when you pull your AMP, into your thing to set up all the sources, name it all through your software, or through the hyperlink? Is it a hyperlink in, or is it literally a case of sort of a containerized press and then label, done? I see the sort of connection elements, obviously straight away because you showed it to us, but the actual configuration of the EC2 instances that are running the services is all configurable through your software, correct?
It is, yeah. So we're not trying to just hyperlink you into another page. So we wouldn't just hyperlink you into AMP. We may in very extreme cases, but the idea here is that through our existing AMP integration, we would actually pull all the resources that are available, all the camera feeds, things like that, and they would just become elements that you see on the left-hand side. You'd then be able to drag them onto a workflow. You can not only configure the inputs and the outputs, which is what I showed, right? But you also have the ability to configure the device as a whole. So, if it's an EC2 instance, I could go in and plug in. I can see, okay, what image is it using? What security group is it part of? What permissions does it have assigned to it? So it's beyond just the inputs and outputs. That just it's nice to show lines being connected and all the rest of it, but Tapestry goes beyond that because it does need to cover not only the sort of the link configuration or the connection configuration, but also the device and the container as a whole. So when you start looking at EC2 is a good one because it's got multiple layers in there. You've got the actual instance itself, then you've got what applications you're running on that instance, and then you've got the inputs and outputs of those applications. So there's like multi-tiered elements that need to be configured. Now, some of that may already be pre-configured, and that's why I say, one of the nice things, you could actually build macro blocks or some mini threads, macros within Tapestry, turn that into an element that then sits on your left-hand side that you can then drag and drop on to bigger, create more complex workflows. So we do see it as being that, we wouldn't be directing you to AMP. You would be doing all of the configuration within Tapestry.
A big round of applause, please, for Patrick and James and everyone else this afternoon. So we've also had Jamie. Thank you very much, Jamie. Hey. Press subscribe. If you can make sure you put all the rubbish in the bins and drink all the beer, because we don't want to do anything else with that. Please drink all the beer. What else? What have we got over here? We've got any pizza left. Please finish the pizza because we're just going to throw that away.